All right, let's dive into a concept that you interact with literally every single day, probably without even thinking about it: the queue. It's this invisible force that brings a sense of order to our digital lives, whether you're printing a document or, streaming this explainer. So let's pull back the curtain on this fundamental piece of tech.
I want you to think about the last time you were in any line. For coffee, maybe at the grocery store, waiting for a movie. What's the one unwritten rule? You get in at the back, and the first person who got there gets served first, right? It's a system that just feels fair and orderly.
And that's really it. That simple, everyday idea of a line is exactly what a queue is in the world of computer science. It's how computers manage the complete chaos of endless tasks, tons of data, and all our requests, and somehow create a calm, orderly process out of it all.
Okay, so let's get right to the core of this. The entire idea of a queue is built on one simple, absolutely unbreakable rule. And honestly, it's the key to understanding everything else. A queue is basically just a list. New things get added to one end, which we call the rear, and things get taken off from the other end, which we call the front. And here's the kicker. You can only add to the back and only remove from the front. No cutting, no exceptions. And this, right here, is the golden rule. First in, first out. You'll hear people call it FIFO. The first person who got in line is the first person to get their ticket. The first piece of data added to the structure is the first one that gets processed. It's this principle of fairness that makes queues so incredibly useful.
So we've got the rule down, but how do we actually use a queue? Well, in the world of code, it really just comes down to two basic actions: putting something new in the line and taking something out.
Adding a new element has a fancy name, Enqueue. It's really simple though. A new item shows up, it goes directly to the back of the line, the rear, and that rear marker just scoots over to this new last position. Super easy, super efficient. And on the flip side, taking an element out is called Dequeue. We always take from the front. That first item gets dealt with, it's removed, and the front marker just moves up to the next item in line, which is now ready for its turn. But, and there's always a but, this really simple approach, especially when you use a basic list that has a fixed size, it runs into this surprisingly common and, frankly, really frustrating problem. It's the kind of thing that can grind a whole system to a halt. Okay, imagine this scenario. The system is telling you the queue is full. It can't accept anything new. But when you actually look at it, you can see a bunch of empty spots. It just doesn't make sense, right? How can something be both completely full and half empty at the same time? This slide shows the problem perfectly. So as you can see, we already processed items A and B, so our front pointer has moved up to slot number 2. But now look at the rear. It's at the very end, at slot 4. The system thinks the queue is full because the rear has hit the wall, it can't move any further. But look, slots 0 and 1 are totally empty. This isn't just a weird quirk, it's a huge waste of resources. That's memory just sitting there completely unused. So clearly, we need a smarter way to use those empty spots at the beginning of the line. And thankfully, computer scientists came up with a really elegant solution to this exact problem. Say hello to the circular queue. Instead of thinking of it as a straight line that hits a dead end, I want you to picture it as a circle. When the rear gets to the very end of the list, it doesn't just stop. It cleverly wraps right around to the beginning, ready to start filling any of those empty spots that were left behind. And when you put them side by side, the difference is just night and day. A linear queue hits a wall, it gets stuck, and it wastes space. A circular queue is so much more efficient. It uses every single available slot by looping back to the start. No more wasted space. It's a game changer. Now, the circular queue is a fantastic fix for efficiency, but sometimes you need a tool for a much more specific job. And so, computer scientists have developed specialized queues with some extra abilities. We can call them superpowers if you like. This table gives us a quick rundown. We've talked about the linear and circular queues, then there's the double-ended queue, or Dequeue for short. With this one, you can add and remove items from both ends. Think of it like a line where people can join and leave from the front and the back. And then you have the priority queue, which actually breaks our main FIFO rule, but for a very good reason. See, in a priority queue, it doesn't matter who got there first, it's all about who is the most important. An element with a higher priority gets to jump the line and go straight to the front. The best analogy is an emergency room. Patients are treated based on how serious their condition is, not on what time they walk through the door.
So, all of this might still seem a little abstract, a bit technical, but the truth is, you interact with queues constantly, every single day. They are the invisible scaffolding holding up our entire digital world.
Seriously, think about it. Every time you send a bunch of documents to a printer, they line up in a queue. Your computer's processor is juggling dozens of tasks at once using complex scheduling queues. When you submit a help ticket to customer service, it goes into a queue. Even the data streaming to your device right now is being carefully managed in queues to make sure every little packet of information arrives in the right order for a smooth experience.
So the next time you find yourself waiting in any kind of line, just remember the simple but incredibly powerful logic that's at play. Queues really are the unsung heroes of our digital world, quietly turning total chaos into a predictable, orderly, first-come, first-served process. And without them, our digital lives would be an unpredictable, jumbled mess. They are the simple, elegant solution to one of the most basic problems in computing: how to be fair.